Now that we've done fraction or integer equations with integers and decimals, we're now going to look at equations with integers and fractions. The easiest thing to do with fractions is to get rid of the denominators, because that's in reality when we see fractions, or when students see fractions, it's kind of like your eyes kind of glaze over and you just kind of want to make it go away and poof, vanish. And so one way to do this is to get rid of the denominators, and we do this by multiplying everything by the common denominator. And that means every variable, every constant, everything on both sides gets multiplied by the common denominator. And then that clears the denominators, and then all you have is the integers. For mixed numbers, make them improper first, and then clear the denominators just as you would, like I said above. If you have a combination of fractions, mixed numbers, decimals, still multiply by the common denominator, because remember that decimals technically have a denominator of 1 the way that integers do. And then once you get rid of the fractions, all you're left with are decimals and integers, and those are much less intimidating to work with. So taking a look at example number 7, we have negative 1/4 a equals 3/8. Once again, I have filled in all the work for you, and then for this first example, I've given you the justification. Should look pretty similar to the decimal integer justification. Now, first, obviously, remember that that first column is just the example. You really don't have to include that column, nor do we need the spaces below it. It's mainly the work and justification columns that are the important ones. So this chart should look pretty familiar, very similar to what we did with decimals. We have negative 1/4 a equals 3/8, and our goal is to get a by itself. We do this by multiplying all terms by a common denominator of 8. So we multiplied the negative 1/4 a by 8, and we multiplied the 3/8 by 8. When we multiply negative 1/4 a by 8, we are saying 8 over 1 times negative 1 over 4. Now what this means is we're then going to say 8 times negative 1 over 1 times negative 1. And that, or excuse me, not negative 1. And that gives us negative 8 over 1, over 4. So it's negative 8 over 4, and when we simplify it, that's how we end up with the negative 2. For 8 over 3/8, we're saying 8 over 1 times 3 over 8, which is 24 over 8, which simplifies to 3. 24 divided by 8 is to 3. So that's what it means when it says to multiply all the terms by the common denominator of 8. Then we're left with the equation negative 2a equals 3. Now we do the inverse of multiplication to get our answer, and then we check it using Pemdas. Should look pretty familiar. Let's take a look at another example. 1/2 plus x equals negative 2/3. Our goal is to get x by itself. Pretty straightforward. Looks exactly the same as every other goal we've written, because we want to focus on what are we doing in this equation. Our goal is to get x by itself. We do this by multiplying all terms by a common denominator of 6. So we are saying 1/2 times 6 over 1, or 6 over 1 times 1/2, which is 6 over 2, which is how we get 3. We are saying 6 times x, which is 6x, and then we're saying 6 over 1 times negative 2 over 3, which is negative 12 over 3, which simplifies to negative 4. So that's where the 3, the 6x, and the negative 4 came from. Remember that with 6 times x, we're just saying 6x, but I didn't forget to multiply that by the common denominator. Everything gets multiplied by the common denominator. At that point, we have what's called a two-step equation. We know it's a two-step equation because we can see two operations in this problem. We see the addition and we see the multiplication. Now we can go through and make our 0 pair with 3. We had positive 3, so to make the 0 pair, we take away 3, because 3 minus 3 would be 0, which means we're left with 6x on the left, and then we have negative 4 minus 3, and using our integer rules, we know that will be negative 7. Since 6x means 6 times x, we do the inverse of multiplication, which is division, and then we get our answer and we check it using order of operations. Since it was a two-step equation, we knew we had to check it twice. Excuse me, we knew we had to have two operations to check it. Or, my suggestion is to always go back to the original equation. So even though we cleared the denominators and got a two-step equation, go back to that original equation of 1/2 plus x equals negative 2/3. Get your common denominators and then solve it, and then check it. Looking at example 9. Once again, I have given you all the work. All you've got to do is figure out what did I do in each step. So we're going to go through and write out our justifications. First, should be pretty obvious. It's our goal. Get n by itself. Pretty straightforward, nothing too difficult. Now let's take a look at the second step. In the second step, what did we do? Well, what's different between the first one and the second one? Notice that negative 2 3/4 became negative 11/4. So what we did was we made negative 2, and we made the mixed number improper. If you want to write instead of the negative mixed number, if you want to write negative 2 3/4, that's fine. I can't type in negative 2 3/4, so that's why I just wrote it that way. So our next step is to multiply by a common denominator of, what's our common denominator? 20. Our common denominator for both of those is 20. And so we multiplied everything, the n, the negative 2 3/4, and the 1 4/5. Oh, and I'm sorry, on the second step we also made 1 4/5 9/5. So we made that one an improper fraction as well. Here's how the math looks for turning those improper fractions being multiplied by 20, how we got those answers. So we have 20 over 1 times negative 11 over 4, which equals 220 over 4, negative 220 over 4, which can then simplify to negative 55. We then have 20 over 1 times 9 over 5, which equals 180 over 5, which simplifies to 36. So that's where the negative 55 and the 36 came from, is when we multiplied those. And then 20 times n is just 20n. Moving along, we now see we have a two-step equation. And without those decimals, it looks a lot less intimidating and a lot less scary, which is our goal, right? We don't like those fractions. When you look at that first one with those mixed numbers, that looks kind of scary. And it's one that a lot of students are going to avoid. It's got negative, it's got mixed numbers. That's just, we don't want to deal with that. Whereas when we see 20n minus negative 55 equals 36, that doesn't look so scary. It really doesn't look too bad. So we look at this and we say, okay, what did we do next? Our next step in our justification are to make a zero pair with, what did we make a zero pair with? Negative 55. Again, notice that for both when I'm telling you what we're multiplying the common denominator by and when we're making the zero pair, I'm not just saying that I'm doing those. I'm telling what I'm making what the common denominator is. I'm telling what the zero pair is being made with. So we made a zero pair with negative 55. Since we said minus negative 55, we added negative 55. And 36 plus negative 55 is going to equal negative 19. Now we have to do the inverse of multiplication, because 20n means 20 times n, and the inverse of multiplication is division. So we divide negative 19 divided by 20. Now at this point, you have a choice to make. If you want to actually go through and divide 19 by 20 by hand, or negative 19 divided by 20 by hand, if you want to do that, you go for it. That's negative 0.95. But most students don't want to go through that process. So my suggestion is leave your answer as that fraction. Leave your answer as the fraction, negative 19 over 20. It's okay to leave it that way. It's not wrong to leave it that way. Okay? Sorry, I'm fixing my colors. So don't stress over it. Leave your answer as the fraction. Now our last step is to check using Pemdas. And remember to go back to the original equation of the negative 19, or n minus negative 2 and 3/4 equals 1 4/5. Go back to that original equation. You'll notice that I didn't make anything into a decimal, and let me sort of state why. The reason I didn't change anything into a decimal is because changing things into a decimal won't work every time. It will work sometimes, but it's not going to work every time, and so because of that, that's why I didn't do it. I want to give you options that are going to work every time. On to the the 10th example, fourth one for this video. 1/5 k minus 3 equals negative 3 1/3. So no big shocker, we have our goal. Get k by itself. And then what did we do in the next step? What looks different? Hopefully you've noticed is we made the mixed number improper. We made the negative 3 1/3 into negative 10/3. Then what did we do in the next step? We multiplied by a common denominator of 15 because our denominators were 5 and 3, and the common denominator in those cases is going to be 15. So we said 15 over 1 times 1 over 5 for the 1/5 equals 15 over 5, because 15 times 1 is 15 and 1 times 5 is 5. 15 over 5 is where we get 3 from. So that's how 1/5 k being multiplied by 15 became 3k. Then we have the minus, then we have that 3. We can't forget to multiply by the common denominator, which is 15, and 15 times 3 is 45. Equals, we then have negative 10/3. So we have negative 10 over 3 times 15 over 1, which is negative 150 over 3, which simplifies to negative 50. So that's how we turned that 1/5 k minus 3 equals negative 10/3 into the equation 3k minus 45 is negative 50. Next thing we did was we made our zero pair. With 45. Because that's the number that's on the same side of the variable, but it's not with the variable. So, and remember that when we went through the steps for solving an equation, we have to get rid of that 45 first. Think of it as when we were drawing the pictures, we got rid of the squares, got them together, and then got the triangles together. So we made the zero pair with 45. Since the equation said minus 45, we have to add 45. And that's where we get k equals, or 3k equals negative 5. Taking us into the last step of k equals negative 5 over 3. So we do the inverse of multiplication, which is division, to get our answer. Remember that 3k is going to be multiplication, and to get the answer we have to do the inverse, which is division. And then to check our answer using Pemdas, what we did was we plugged in negative 5/3 into where we found k, and then we solved the problem. Please note, you cannot make this one a decimal, okay? The reason for that is the thirds, the negative 3 1/3, if you were to make that a decimal, it's going to be a repeating 3. It's 3-point repeating 3, and that's not going to work, okay? All right. Number 11, 1/6x equals negative 17.1, excuse me, 1/6x minus 17.1 equals negative 18. Our goal is to get x by itself, and we do this by multiplying all terms by a common denominator of 6. There's only one fraction, so of course that's the common denominator. So we multiply 1/6 times 6 over 1, which equals 6 over 6, which is how we get x. If you want to write an invisible 1 before it, you go right ahead, but you don't have to. Then we also have to multiply the 17.1 and the negative 18 by the common denominator of 6. Everything gets that common denominator of 6. So what did we do next? After we multiplied all terms by a common denominator of 6, we made a 0 pair with 102.6. And that is how we got our answer. Now, in this, since we were saying minus 102.6, we are going to make a 0 pair, we would add 102.6. And then when we check using Pemdas, we are able to go back to the 1/6x minus 17.1. And in this case, you're going to have to do some real thoughts on the multiplying, but feel free to use that calculator if you need to, or you can make the negative 5.4 into an improper fraction, and from there, follow through with checking it. It's so important to check your answer. It takes away that anxiety of, did I do it right? Is my answer correct? Takes all that anxiety away. And so we want to remove that anxiety. We want to make sure that you're like, okay, I feel good about this. I know what I'm doing. And on to 1/3 parentheses 6y minus plus 12 equals 5. So the goal is to get y by itself. Now in this case, a lot of times students go, oh, we need to multiply by the common denominator of 3. Before we do that, there's this step called distribute. And the reason we want to distribute is because a lot of times by distributing, that's going to take care of the fractions for us. So we can say 1/3 times 6y plus 1/3 times 12, and that equals 5. So all we did was distribute. And the reason that's going to work at clearing the fractions for us is because 1/3 times 6 over 1 equals 6 over 3, which simplifies to 2, because 6 divided by 3 is 2. And 1/3 times 12 over 1 becomes 12 over 3, which simplifies to 4. And now that that's done, we have gone ahead and cleared the denominators without having to worry, without having to go that extra step of the common denominator. So we then go on to making a 0 pair with 4. Since it was adding 4, we can now subtract 4. And then we're going to go through and do the inverse of multiplication. We know we're doing the inverse of multiplication because 2 times y, 2y means 2 times y, and the inverse of multiplication is division. We get 1 divided by 2. Again, if you are wanting to do the decimal form, go ahead and actually multiply it out or divide it out, fine, but you do not have to. So we're left with y equals 1/2. And then last but not least is we need to check our answers using Pemdas. Again, go back to the original equation where it was the distributive property and use order of operations to solve it. Congrats on solving equations using integers and fractions.